Hey guys, what's up? Rex again here with TorchPrep. I'm here in test 2, problem number 28. Okay, so what I want you to do is pause the video right now, open the red book to test 2, problem number 28. Read the question, press play again when you're ready. All right, so problem number 28 on this test. I'm just going to let you know, in my opinion, this is the most evil question on the test. I didn't say it was the hardest, but I'm going to say it's the most evil. If you're looking at this and finding out that for x is greater than 21, what is true of the following expression? It is. I'm looking at it. The whole thing right here is it's pretty tough. Looking at it all, because what you have for the answers is some numbers and also some simplified forms of expressions that might be from this. Amazingly, this question is so easy. That's why this is such an evil question to me. So mean, but we can do this. All we need to remember how to do is take these trinomials and break them back down into binomials. We're going to take the FOIL method. We're going to unfoil these trinomials, okay? Watch as we do this. I want you to know how to take these apart and look at this very complex expression in the form of a fraction, and we're going to see how simple the answer actually is. Okay, so all that being said, if you look at this and are pretty confused, for about 30 seconds you're still in the dark. We know what time that means. This is when we skip circle number 28, smile, and move on in our survey portion. Come back to this in the work portion. I absolutely would suggest this is a work question, not a survey question. So now that we're in the work phase, let's attack this thing. And let me tell you a little secret. The thing that started to throw me off until I realized. This information over here is completely not helpful. You don't need that information. That's what was throwing me off when I first looked at this question. This is an evil question. What I'm going to do over here is I'm going to try to simplify this in the best terms possible, okay? Just to make it easier, you know what I'm going to do? I'm going to pretend to multiply both sides by my denominator, just to pretending like this is a normal equation. So I'm basically going to take my denominator and slide this guy up here. Let me show you what I mean. I'm going to rewrite this whole thing down below. So I have x squared plus 8x plus 7. That's all a nice little set of parentheses. And then I got x minus 3. And then put that on the opposite end, just to simplify it visually. And you know what? I will tell you this. I'm going to put this side back under in just a minute. I just want to pull it apart, make this visually a little easier to work with. That fraction is freaking us out. It is hard to deal with. Let's just not deal with it in a fraction. Let's take one part at a time. Good. So what I'm going to do is I'm going to leave these two binomials alone. I'm going to take each of these trinomials and I'm going to unfoil them. I'm going to think, what two binomials could I get to create this? So two binomials, they're going to look like this, aren't they? They're going to be smaller. They're going to have two terms inside of them. And they're going to be something like, yeah, this is a binomial. We have the x minus 3. So let's look at this. The first term, if it became x squared, if you're good at FOIL and you're taking two binomials and putting them together, but you can figure out what this one would be. What two things multiplied together would get us x squared? X over here, x over there. Remember our FOIL method. First, outside, inside, last. So if I think the first two terms multiplied together should give me something, perfect. Now, I want to skip outside and inside. I like going to last. I do first, when I'm unfoiling, I like to do last. What two things multiplied together would give me 7? Well, 7's a prime number. So only, whole numbers-wise, 1 and 7, right? 1 and 7. Now, I didn't put a plus or minus between these yet, because I want to think about how outside and inside would work for this 8x. Let's think about it for a second. If I have outside x times 7, that's 7x. 1 times x, that's just x. So then I have 7x plus x. That does equal 8x. This one was pretty easy. And I know this 8x is positive, this middle term in my trinomial. So look, I've broken this down. It wasn't as hard as it looked. I got x plus 1, an x plus 7, and an x minus 3 over there. Let's do the same thing on the other side. Over here, I'm going to create two new binomials from this trinomial. And I'm going to keep this one. We're going to put it all in a form similar to this. And this is the same thing over here. They made it easy on us. What two things multiplied together would their product be x squared, x and x? Again, I already did first. I'm going to look at last now. What two things multiplied together would be negative 21? Well, 21 is not actually a prime number, but of course we can always start with 1 and 21. 1 and 21, I don't think added or subtracted together will get me near 4, so I'm going to ignore that one. And of course, multiplication table-wise, we know 7 and 3 would work, right? 7 and 3. Here's interesting, though. That's a minus 21. I know one of these has to be positive, one of these has to be negative. Before I decide which one, I've already done last for my numbers. I'm going to do the outside and inside. Let's just throw a random one on here. I'm going to do x minus 7 and then x plus 3. Let's see what happens. So if I did outside now, I'd have x times 3, okay? That's 3x, and then negative 7x. If I put those together, I would get a negative 4x. But that's not what I have up here. I have a positive 4x. You know what I realized? All I'm going to do when I have that incorrect is then I'm going to switch the symbols. If I see a negative in here, I know there's got to be a negative for this last term. But if I'm looking for the outside and inside, let's try this now. Got 7x in our inside, negative 3x in the outside. 7x minus 3x, that'd be 4x. Boom, we got it. Now, what I'm going to do, I want you to ignore these top terms. Ignore the trinomials we had at the beginning, because now we have them broken down into cute little binomials. Remember, this portion represents the denominator that we moved over. I am just going to move this bad boy back down. So all I'm going to do is move this thing back down here. And you're going to start to see, or maybe that you've already figured out why this is so easy. It is so evil and easy. Now, if you take a look at this, we have 3 binomials on top of 3 binomials. Look at them closely. You will see that each one has a pair on the numerator and denominator. I could have even rewritten this one and put them in the same order as the numerator. And I think we've all learned, when you have a fraction and you have the same number over the same number, what does it equal? If I have 9 over 9, that equals 1. If I have x over x, it's always going to equal 1. So if I have the same thing over the same thing, this entire expression is going to equal 1. And if you look at your answer choices, 1 is answer choice letter F. This whole time, this big wild thing equals 1. They just wanted to freak you out. Don't freak out when you see something like this. To simplify, we will unfoil these big trinomials, pull it apart. Before you freak out, once you're in the work session, not when you survey, take it step by step. Once you see, they often are not that difficult. Great job. Move on to the next question.